Okay, I'll put that with 15% more than 30. Thirty plus 0.15 times 30. And you calculate it from there, 0.15 times 30 is 4.5, add that to 30, you get 34.5. You should verify. That 1.15 times 30 is the same as 30 plus 0.15 times 30. Why? Because 1 times 30 is 30, and 0.15 times 30 is 0.15 times 30. You should understand the distributive law. Okay? Something you could look up online if you're not comfortable with it. Somebody out in the hall made a note, let me call us an investigator. Okay, now your question was, I think connecting this to this is the way I understood it, but it turns out that somebody else explained it to you, which I greatly appreciate, and that's a good explanation. And you obviously understand it very well. Okay, very good. So, this 30 is here because you get to keep your $30, let's say, and add 15% to it. If you just do 0.15 times 30, all of a sudden you've lost $25.50. Okay? Because you just, apparently you threw away your 30 and just kept the 15%. Okay? But it says 15% more. Okay? So we have to understand how to calculate that. And that's actually very important. And this is very fundamental to the way compound interest works. But we're not going to get into compound interest. Probably not at all in this course. Okay. Now again, since you get to keep your 30, you got to have a 1 here. If you didn't have a 1 here, you wouldn't have a 1 to multiply the 30, and you wouldn't have 30, right? And then you have your 0.15 times 30 here. Of course, now you can just add the 1 and the 0.15 and do this with a single calculation. You don't have to add anything, it's already there. And you just multiply this by 30. You get 34.50. That's an important thing to understand. Okay. So on a test, and we're probably going to have a test pretty soon because we're about to transition into the actual intermediate algebra. Okay. So we want to make sure that you bring all the elementary algebra together. Okay. So anyhow, you have that. Okay, well, now 30% is 15% more than what? Well, this says basically don't know what is. Say write that as 30 is 15% more than something we don't know. And we traditionally use X for something we don't know. Okay. So it says 30 is 15% more than X. What does this say? This says that 30 does so many times, it just kind of rolls right off my wrist. Okay. X this has X plus 0.15 times X equals 30. Because this is 15% more than X, right? Just like 30 plus 0.15 times 30 was 15% more than 30. X plus 0.15X is 15% more than X. Okay. So this translates as an equal. The 30 is just 30. Now we can do the same thing here. And we have to do it in this case. We add, well, let me do both steps. I don't want to emphasize distributive law. Same way I did before. So So 1 plus 0.15 times X is 30, right? So that (1.15X is 30. At this stage, I really want you to be in the habit of writing out steps, but I did leave myself room. You would divide both sides by 1.15, right? And the 1.15 you divide by here would divide into this one, leaving it X equals 30 over 1.15. Okay. And then you can punch that into your calculator. It'll be on the order of 6,730, which would be 1.3 times 7. So, yeah. 4.3 is 25. Okay. So it's going to be about 25.67. And there's a question in this. So I did that in my head, but you can punch it into your calculator and get the result. Okay. And of course, it'll be a long decimal number. It'll start repeating after about 5 digits, but around that all 25.7, I'll round it off to the nearest penny, which is what a financial transaction is. Okay. So, don't understand that? Well, first, you haven't done the assignment. A lot of you haven't. Go to the half credit page and do it. Okay. Because it'll illuminate a lot of it. You'll see the same type of stuff explained by Open Math. Then you can choose to take another look at my explanation or just put one of the Open Math explanation. Now, I remind you, because I see evidence that people are doing it. After you get the Open Math explanation, you understand it, and then you put it out of your sight and do the problem. And if you can't do that, you didn't get what you need to do out of the problem. Okay. If you have to routinely just follow the steps of a solution that you see, okay, but then do another problem later until you can do it without having to have an example in front of your face. Okay. Because you don't know it unless you can do that. And actually, you're going to have to come in here and do something, right? And which you're doing pretty well. Now, this, you know, you didn't do quite as well on this because most people didn't get the assignment though. Okay. And then people were looking for the half credit page. So let me just verify. There's your course ID and there's your access code, whatever you call it. Those are the two numbers you need. And everybody should get into that. Okay. if you get that done for the next class, I'll transfer the grades at this one time. Normally, I just transfer it. Okay. Okay. So there it is. That is some advice on how to learn. You know, don't think you've solved the problem if you follow another example step by step. Okay. Now, if it's another example that you have to adapt to the problem, the other example isn't exactly the same, and the steps are a little different, well, that's kind of valid. Okay. But make sure you're learning it, make sure you can do these problems without having examples in front of you. And that goes for the, you know, especially the problems that don't have videos, don't have any help with them. You need to be doing those independently, and if you can't do them independently, you better review the ones you did with help. Okay? Because with the open math, the way it's set up, it's pretty easy to get the points without learning anything, without learning much. Okay? Remember, your goal is to be able to come in here and do them. All right. Now, I think everybody did real well with the inequalities, because everybody's been doing really well with the linear equations. Okay. One thing that people came up short on is how to graph solutions. And if you did do the open math homework and missed it when I did it in class, which I think I've only done once or twice, this need to, yeah. Okay, so, and you need to check. And y'all have been really good about checking your work. You're doing it routinely. Okay, never seen a whole class that actually checks the book. Okay. Y'all look like the same species, so I just assume that we got some good people here. Okay. So, you're there, you're full of some kind. Okay, anyhow, we got 2x minus 4 less than 5x plus 3. Now, I don't have a lot of room, so I'm going to do 2 steps at once here, but it's fairly obvious. To get the x's on this side and the numbers on this side, we've got to subtract 5x from both sides. And then we've got to subtract or add 4 to both sides, right? So I'm going to do that all in one. 2x minus 4 minus plus 4 minus 5x is less than 5x plus 3 minus 4 plus 5x. Everybody see that? Pretty well. I had to write it kind of small. But the point is, I've got the 4 minus 5x. That's got to be added over here. We've got a plus 4 minus 5x here. We've got a plus 4 minus 5x. Got my minus and plus mixed up there, so I've got to watch myself. Okay. And you watch me too. Okay. So now we have the same thing on both sides. And now, when we subtract 4 and add 4, that leaves us 0. And we just have 2x minus 5x, which is 3x. Now, it's fine if you want to do this. Okay. If you want to do it in 2 steps, the way we do it. Okay. If you need to do that, go ahead. But yeah, take a look at this. Try to understand how that works. We're just doing 2 steps that you would obviously do, but we do it in one. Okay. Like we choose to subtract the 5x to both sides. We'll get rid of the x's over here. And then we would add 4 to both sides. Well, we just do it all at once. Okay. And that's going to give us 7. Okay. Now, do you want to write out all our steps? Anything wrong with what I wrote down? Yeah, the one rule you have for inequalities, you got to reverse the inequality when you multiply or divide by negative. I can read your gesture, not your mind, but your gesture. Okay. Okay, so we gotta make that greater than. Don't make the mistake of multiplying or dividing by a negative quantity and failing to switch, reverse the inequality. So we get x is greater than 7 over -3. Now, how do we graph this? Well, we underline down here. And you put -7/3 here. We don't include the -7/3. We use an open dot. Yeah, let me do this in different colors. See, okay. And then everything greater than that. Okay. What's a number that you know is greater than -7/3? Some integer. Just hold up fingers for an integer that would lie to the right of -7/3. Okay. Yeah. Yeah. Any positive number would be. I think I got 2, 3, 4, and 5 on it. Okay. So I'll just use 1. I could use 0, but I'll just use 1. Okay. And clearly, if -7/3 is here, well, we don't know where 0 is. Okay. Until we put 0 in there, we put 0 in there. Now, this is -2 1/3. Right? -7/3 is over 2 1/3. I did something egregiously ignorant with my arithmetic. Okay. And I do that regularly. Okay. So we have -2 1/3 here. 2 1/3, which means that -2 would be maybe here, and -1 would be here. So 1 would be here, 2, 3. Put 0 any place on work, it's convenient to put it there. Okay. And now we've got a scale. Of course, we go to -3. And so forth. But clearly, 1 is in the set of numbers that's greater than -7/3, right? That's a check. And also pick a number that's less than -7/3. It isn't greater than -7/3. Well, turns out -7/3 is between -2 and -3, right? So let's just use -3. It's -3 greater than -7/3. Well, -7/3 is -2 1/3, right? And -3 is less than that. The left number line. So it isn't greater than -7/3. So we understand this graph is representing all of the numbers that are greater than -7/3. Okay, and open math tells you that. And I just realized, I had this thing zoomed. Oh, wait a minute, it's okay. It's okay. It's going to show you. All right. Okay, well, do the same thing with -4x plus 2 greater than or equal to 8. You'll put dots in for step you ought to fill in. You're going to get -4x greater than or equal to 6. Because you're going to subtract 2 from both sides. And then you're going to get x. If you just write it out wrong, you write greater than or equal because you're going to divide by -4, right? And I probably ought to step in. As soon as I divide by the -4, I reverse the inequality. And of course, 6/4 simplifies to 3/2. So x is less or equal to 3/2. It's less than or equal, so when you graph it, there's the negative 3/2 here. I'm going to put a closed dot on it. And it's going to be here. Okay. Now we can pick any number to the left of negative 3/2. And negative 3/2 is negative 1.5. I think something right. Start right fraction on the road again. Okay. Okay. And as I said before, we don't do a lot of math with mixed numbers. But when you got to locate something on the number line, you kind of have to have the mixed number to know what two numbers it's. Okay. So negative 3/2 is between -1 and -2, right? Now, if we take -1 and plug it in to the original equation, what do we get? We get 4 plus 2, which is 6, is greater than or equal to 8. And 6 isn't greater than or equal to 8. So let's check here. -1 is not on our arrow. So it should not satisfy the equation. Well, -4 times -1 plus 2 is greater than or equal to 8. Is that true? Well, this gives us 6 greater than or equal to 8. It's false. That's okay. Because it's supposed to be false because -1 is not in the region that we shaded. It's not on the arrow. I'm not going to write out the steps to say this one, but if you put a -2 there, we get 8 plus 2, which is 10, right? Well, you get an okay for a number outside the arrow, close by, a number inside the arrow, close by. You think it's probably true. The other thing you want to check maybe is if x equals -3/2, are these two equal? Well, 3/2 of 4 is 6. 6 plus 2 is 8. They're equal. Okay. So you want to check that as well, but reasons of space and the idea that you need to go on, I'm going to leave it at that. Okay. When I threatened to record it, it suddenly went into focus. Okay. Even the picture didn't help. Okay, absolute value of x greater than 5. I gave you the examples. Absolute value of 12 is 12. Absolute value of -15 is 15. Absolute value of -3 is 3. Absolute value of 5 is 5, right? Okay, and then I ask you to list several numbers that satisfy this. You know, 5 or 6 numbers on the right, 5 or 6 numbers on the left that satisfy this. And then 5 or 6 numbers on the right, 5 or 6 numbers on the left that don't satisfy. Okay. So show me with your fingers a number on the right that does satisfy this. Okay. Absolute value of a number that's greater than 5. What's the number? Okay. Okay, everybody's holding up 5 fingers and then some more, right? Because if the absolute value of a number is going to be greater than 5, If the number is positive, that number has to be greater than 5. So we could go 6. So that's yeah. Okay, so I think I saw most of these numbers. Your fingers, right? Okay, now can you give me some numbers to the left of 0 that satisfy it? Okay. Okay, now we got -3, which would be about here. Okay. And what's the absolute value of -3? It's the absolute value of -3. It's 3. Okay, so 3 is to the left, but it's not a solution to this equation. So what I want to do is find a piece of chalk that I should be able to find easily. Okay. To contrast the numbers that aren't. So I'm going to put a red mark on this one because it's not. So, okay. Now, can everybody give me a number? Just do like -2. Right? Do the negative and then show me some figures, okay? Go ahead. Okay. Not you're saying -5, but -5 is close because the absolute value of -5 would be 5, right? If 5 isn't bigger than 5, 5 is equal to 5, right? If this is a greater than or equal sign, then you would include 5. Okay? So try again. Okay, there we go. Okay. Well, -3 we tried and it doesn't work, but I'm getting numbers like -6, -7. Oh, and I've got the wrong color. Oh, man. It's almost an unrecoverable error. Maybe pull it off slash harder to read. This piece of chalk I had at hand. Okay, so we got like -6, -7, -8 are all white as opposed to red. Okay. And all the white ones satisfy the equation. Okay. Now show me a number that doesn't satisfy this to the right of the number line. Okay. 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 Yep. Good. Okay, so we got, I think -1. -2. -4. I'm not spacing these apart. There it is. Okay. Now, what about -5? Well, as we saw, the absolute value -5 is equal to 5, but it's not greater than 5. So -5 would also be among the numbers that is not in the set, or not in the, not a solution. And the numbers up to 5 would be solution, right? Now, what about 5.000000000001. That's greater than 5, isn't it? Okay. And that's really close to 5 on the number line. So any number to the right of 5 is going to work. So what I can do now, if I want to put this set, is put a circle, an open circle around 5, and an arrow to the right, and an open circle around -5, and an arrow to the left. Okay. Now, if you want to write this as a set, it's the interval this is the interval 5 infinity. This is the interval good if I start paying attention to what I'm going to say before I write it down. Okay. This is the interval -infinity, -5. You wouldn't write it -5, -infinity, even though you kind of think it goes from -5 to infinity, because it's always the lesser and then the greater. Okay. You're always going from left to right when you write down the numbers in an interval. Okay. So there's this set, and there's this set. In the solution set, is -infinity, -5, union with 5 infinity. Okay. Now you've seen that notation, I believe, in open math. I've used it some here. Which means the interval from -infinity to -5, equal 5 to infinity. And one way you can read this, or one way you can understand what it says is this is another way of writing x is less than -5, and this is another way of writing x greater than 5. And a union means it's in one set or the other. X can't be here if it's here. It can't be here if it's here. It can be here or here, and it's a solution. That's the reason for the word or. If we wanted to say and, then there's a temptation to do that. If we put this together with this, so we got this set and this set, making up our solution set. X can't be less than 5 and greater than, sorry, X can't be less than -5 and greater than 5, right? As these two sets are disjoint. They're separate from each other. They don't have any overlap. It can't be in this and this, it's in this or this. Now I stress that because I want you to kind of think about it. It's an important word and understanding the logic of the steps. And that's important in a lot of applications. Okay. That's why we use or you. All right. Well, as far as this goes, let's try another one then. Let's try. Well, first of all, let's try absolute value of x is greater than none. Okay. Now we know what we've seen, that this says that x can be less than -9 or x greater than none. All right. Understand that? Because solution to this can be expressed as this set, it can be expressed as this picture, it can be expressed as this or. Yeah. So, Okay, we had a good question. So when you're answering these questions, do you want to write a union or do you want to write or? I believe open math is going to want the union. Okay? But when you're solving an equation and writing it out, you're going to put it in or. Okay? Now, another thing, starting maybe with this upcoming assignment, but maybe not until the assignment after Thursday. I think maybe for the upcoming assignment, you'll be asked to submit or to upload a picture of your work. Okay? You should be able to easily do that with your device. Okay? If you have trouble doing that, since I don't use devices, I do that with the advisor on it, so you just download a scanner app. And if you don't have that ability on your device or don't know how to do that, I'll recommend that you go over to the tutor center and ask somebody, because they're going to have a better idea how to use different devices than I do. Okay. I mean, I don't use devices because I don't want to walk around like this. Okay. And especially I got some neck problems. I really can't do that. But even before I had the neck problems, you know, my posture's into this, so I don't want to make it worse. Okay. Anyhow, so I don't use my iPad. I can't do it on the computer. I don't want to do it. On the other hand, people never seem to have much trouble at all downloading a scanner app or creating a file with JPEGs. You can. So and I asked if that be, I put a note in the thing. Asked it to be legible, make sure it's big enough for me to easily see it, because I don't have a lot of time to manipulate. I don't want to upload PDF into Adobe. I want to be able to view it right there. Okay. Because it takes time. Adobe takes time to upload these things. And I can't move through them as quickly as I need to, which is frustrating. You don't want to evaluate your homework. Okay. Only mildly frustrated. So like that. So if you do it wrong, I'll let you know and get it straight over the next couple of assignments. I don't want to see that. Okay. I see how you're writing it out. And I know that you are, because you're doing it on your quiz. But still, there's often something I can spot that can be useful to you. I see it in your homework when I have the document right in front of me. I can navigate it. I can see what I'm looking for very quickly, rather than having you open your notebook and stuff, taking up a lot of class stuff. Okay. Makes sense? So I'm asking you to do the next 5 points. It's worth 5 problems. Sometimes more than 5, you know, 20 more problems. I think we keep asking for 6. I might even give you 6 points. As long as it's a decent upload of your homework. I'll give you the points, even if it's all wrong, as long as there's a reasonable effort behind it. Okay. So not necessarily grading your written work, although there's no effort if you haven't get it done. Okay. But it's easy points to do something and convey the message. Okay. I'm repeating myself. So move on. Okay, well, we want to take the idea here that absolute value of x greater than 9 can translate into 2 inequalities, both of which you can easily solve. Linear inequalities. They're not always linear, and they can be harder to solve than they are. But for the present, the only kind of equations I assume you know how to solve is linear equations. And you know, are linear inequalities now. And I believe you're always very good at that. Okay. Okay, let's take another one. Let's take absolute value of x minus 4 less than 3. Okay, we're short on time, so I'm going to tell you. If it's greater than, it breaks into two inequalities with an or. Okay? If it's less than, if this was absolute value of x less than 5, then we'd be shading the red area here, wouldn't we? It's absolute value of x is less than 5 between here and here. Okay? So that means that the absolute value of x is less than 5. But there are a lot of values of x less than 5, like -6, -7, -8, that don't make it true. It's also got to be greater than -5, right? So it's got to be less than 5 and greater than -5. So if you have a less than or less than or equal, it becomes an and. And it breaks into two equations, x minus 4 less than -3. Less than 3. And x minus 4 greater than -3. Okay? It's a pretty easy rule to remember, but think in terms of this example, why it's and. Again, just being less than 5 isn't enough. It's also got to be greater than -5. It's got to be both, which is and then use this solve that. Okay. Now there's more. Open math will show you, but let that be good. Hopefully, an introduction. There's one more thing. I have to leave myself more time to do this, but we had a couple of digressions. You know, like the whole thing about I gave you the wrong access code. Mostly my fault. Okay. Now that was totally my fault. Most of that was my fault. But I want to do something like this. And I kind of think maybe we did. How do you solve this? Well, you're trying to isolate x. You have a plus b here. That's going to give you do this, subtract b from both sides, we'll end up with ax equals c minus b. Okay. So that should be an obvious step. You're trying to get rid of everything but x over here, right? So we subtract b from both sides. Now don't be tempted to divide by a until you get down to this step, because there's a temptation to just divide ax by a and not divide b by ba. You got to divide both sides by a. It's much easier to do if you just have something times x, like a times x. And then you do ax over a equals c minus d over a. So the x equals c minus d over a. Does that make sense? You're just doing the same thing with the letters that you will come to form with numbers and that you know very well how to do. Okay. So I'm kind of not giving you a whole lot of detail on this, not nearly as much as I'd like. But keep your wits about you, follow the instructions. You're very good with linear equations. And I think you'll be able to pick that up pretty easily in that. Okay. And if not, yeah, we'll deal with it next time. Try to get it done. And then after that, on Wednesday, we move into graphing, which is kind of the beginning of our transition into intermediate algebra. Okay.